Hello dear students, this video is created for education purpose. Myself Meena Labde, Assistant Professor in Mathematics, Maharaja Jivajirao Shinde Mahavidyalaya, Srigonda District, Ahmednagar. Dear students, we have started our SYBSc Mathematics paper 2nd, Numerical Methods and its application. So we are studying our unit number 3, Numerical Differentiation and Integration. This is our lecture number 4. Now in previous lecture we have seen trapezoidal rule for numerical integration. Also we have seen examples based on trapezoidal rule. In this lecture we are going to derive another uh, numerical integration formula, that is Simpson's one-third rule. Again, to derive this Simpson one-third rule we will need general quadrature formula for equidistant ordinates. So first of all, write general quadrature formula for equidistant ordinates. So that is nothing but I is equal to integration a to b y dx. A is nothing but your initial argument, b is final argument, and y dx. So write this formula like this: h outside. What is h here? H is interval of difference in n y naught plus n square by 2 delta y naught plus n cube by 3 minus n square by 2 delta square y naught upon 2 factorial plus n raised to 4 minus 4 minus n cube plus n square delta square y naught upon 3 factorial. So remember this formula because in every numerical integration formula we need this general quadrature formula for equidistant ordinate. So to derive trapezoidal rule, what we have done, we have put n equal to 1 here. Now in this formula we are going to put n equal to 2. So put n equal to 2. Now in the LHS your interval of integration will be from x naught to x naught plus twice h. So how many arguments are there in between x naught plus h is there? So x naught plus h, and x naught plus twice h, and respective values of the function are y naught, y1 and y2. So there are only 3 functional values, and therefore third and higher differences are 0, and since third differences are 0 we are going to neglect this term. So write this formula up to 3 terms, and wherever n is there replace by 2, and let us see what happens. Simplify this. So in the LHS your integration will be from x naught to x naught plus twice h y dx is equal to h outside 2 y naught delta y naught, and remember that formula, you are putting n equal to 2 here. So 2 cube upon 3 is 8, and 2 square upon 2, 1 2 is cancel, and at the numerator you will get 2. So it is 8 by 3 minus 2 delta square y naught upon 2 factorial. Now write here delta y naught and delta square y naught. Simultaneously simplify this. What there becomes 8 by 3. So whatever here denominator is 1. So 8 into 1, 8 minus 6 divided by 3. So 2 by 3, and that numerator 2. So that becomes your 2 by 3, and whatever that numerator is there, that will cancel to this 2 factorial. So I have written here h 2 y naught. Now 2 outside is definition of delta y naught. So what is delta y naught? पुढचा मायनस मागचा y naught च्या पुढचा कुठला आहे y1. So y1 minus y naught plus that 2 will get cancelled, and it's only remaining 1 by 3 and delta square y naught. So let us see what is delta square y naught. So delta square y naught is delta of delta y naught. So this is your delta y naught, y1 minus y naught. So apply delta inside. So you will get delta y1 minus delta y naught. So what is delta y1? Succeeding minus preceding. So y1 च्या पुढचा y2. So y2 minus y1. So this is your delta y1 and this is your delta y naught. So simplify this. You will get y2. This minus 1 times y1. This is minus 1 times y1. That becomes minus 2 times y1, and that minus minus become plus. So plus y naught. So this is your delta square y naught. So simplify this. So you will get h 2 y naught, then 2 y1 minus 2 y naught. So this y naught will get cancelled, and only 2 y1 is there, and this minus 2 y1, that whatever after simplification you will get this equation h by 3 y0 plus 4 y1 plus y2. So check whether this equation is correct or not. So what happened to this? So when in the LHS, when the limit of the integration is from x0 to x0 plus twice h, so h by 3 is common, and functional values are y0, y1, y2. So write in bracket y0, y1, y2, and whichever middle functional value is there, the coefficient of that functional value is 4. So it is simply y0 plus 4 y1 plus y2. Now in similar way you may compute x0 plus twice h2 x0 plus 4h, because we are putting n equal to 2. So x0 plus twice h2 x0 plus 4h. What will be that? H by 3. Now how many arguments functional values are there? y2, y3, y4, and middle is y3. So for middle functional value 4 is the coefficient, so y2 plus 4 y3 plus y4, and for this integration x0 plus 4h2 x0 plus 6h, middle is y5, so 4 times y5 is there, h by 3 y4 plus y6. So in general, I have not written general formula, but general formula is h by 3 yn minus 2, then 4 yn minus 1 and yn. So adding all these, so these LHS you have to add in the LHS. So in as previously we have done in trapezoidal rule, if you add LHS of these equations, you will get the integration will be from x0 to x0 plus nh y dx. Now this is for first integration, this is second, this is third, and this is last integration. So simplify all these, so you will get h by 3 is outside of the bracket. In bracket you will get first term is y0 plus y1, y0 plus yn initial plus final, and then collect the terms of the form 4yi. So 4y1 is there, 4y3 is there, 4y5 is there, 4yn minus 1. So 4 times y1, y3, y5. So observe these suffices are odd numbers. So 4 times y1 plus y3 plus y5 plus y7 plus etc. yn minus 1, and we will get this y2, and this y2 is 2 times y2. So 2 times y2 plus y4 plus y6 plus etc. yn minus 2. So 2 in bracket yi's with suffices even. So remember this formula, and this formula is called Simpson's 1/3 rule. So remember this x0 to x0 plus h y dx h by 3. Why this is called as the Simpson 1/3 rule? Because 1 by 3 is there with h. So h by 3 is there. Very first bracket is initial plus final value of the function. Then 4 times yi, but yi as I must be odd, and plus 2 times yi, I must be even. So 2 times y2, y4, y6, etc. And since it is multiple of 2 and multiple of 3, your n should be even. So remember this Simpson's 1/3 formula is applicable only when number of subinterval is n. N is what? N is the number of subintervals. So this is known as a Simpson 1/3 rule. So remember this formula we are going to use while solving the examples. So let us see example. Evaluate integration 0 to 1 1 upon x dx with h is given, interval of differencing 1 by 6 by using Simpson's 1/3 rule. So first call this integration as I equal to integration 0 to 1. This is your y. Y is 1 upon x dx, and h equal to, so we have written here y equal to f of x equal to 1 by x, h is 1 by 6, and therefore values of each point of the subinterval. So initial your argument will be 0, then next will be 1 by 6, 2 by 6, 3 by 6. So see carefully, we have prepared this table here. So very first row is for the argument. So initial argument is 0, next will be 0 plus h, that is 1 by 6, then 1 by 6 plus 1 by 6 is 2 by 6, 3 by 6, 4 by 6, 5 by 6, and last is 6 by 6, and that is your 1. Again compute y is equal to 1 by x, so respective x put here and get the value of y. So if you put x equal to 0, so initially you will get y naught is 1 plus 1 upon 0, that is 1 upon 1. Then put x equal to 1 by 6, 1 by 6, so at the denominator you will get 7, and third term will come at the numerator, so this is 6 by 7, 6 by 8, etc. So compute these values and check whether these are correct or not. Now we are going to apply Simpson's one-third rule. So whatever these functional values are given, so you may rename as this is y0 and this is y1, this is y2, because we are going to use these values directly. So this is your y3, then this must be your y4, then this must be your y5, and this must be your y6. So here n equal to 6, and therefore your n is even. Now y0, y1 we have written here, so as n equal to 6, which is even, we can apply Simpson's one-third rule. So write down Simpson one-third rule. So it is x naught to xn, y dx is h by 3, y0 plus y1 plus 4 times I must be odd, plus 2 times j must be even, and write the terms up to y suffix 5 is included here, so that y0 plus, instead of yn, that must be your y suffix 6. So put all these values and simplify this, so you will get the answer is 0.6931. So very important thing is that how to use Simpson's one-third rule. Just it depends, answer is depend on the formula. If your formula is wrong, then answer will be wrong. So remember this formula, Simpson's one-third rule. So h by 3 initial plus final plus 4 times I must be odd, and plus 2 times j must be even. And if this formula is correct, then nothing to do, just simplify by using your scientific calculator, and you will get answer is 0.6931. so this is the example based on Simpson's one-third rule. Now I have given you two exercises for practice. So this is exercise, the data is given directly, and just write down the Simpson one-third formula and put all these yi's in that formula, simplify, you will get answer is. Now we have asked area of the region, and therefore the unit is square meter, so answer is 710 square meter. And next is given, so compute the value of log 2 from the formula. So this is formula is given, and we have asked, we have to divide this interval into how many 10 subintervals. So again here 10 is even, and we can apply Simpson's one-third rule. So perform the table like this, y equal to y and x for first row. So what is h here? So first write down h is nothing but b minus a divided by n. So b is what? Upper limit, so 2 minus lower limit is 1, 2 minus 1 upon 10. So h is your 2 minus 1 is 1, so h is 1 by 10. So here first argument you use your 1, then 1 by 10, then 2 by 10, then 3 by 10, up to etc. up to 2, and respective values you have to compute. Y is nothing but y is given 1 upon x. Now this is answer for log 2. Log 2 is no, there is no use of this log 2, just you have to compute this integration, and I have not put here the answer, but you can check at your own, because by using your calculator find out log 2 whatever this is, and again compute this RHS integration by using numerical integration, that is Simpson's one-third rule, and observe these both values must be correct, or there will be a little bit error. So this is all about, let me erase all these. This is all about Simpson's one-third rule for numerical integration. Now we will stop here.